here. First thing is, I'm going to zoom in a lot because did you see this ruler? This line right here is not the 0. This line is the 0. So we need to make sure that when we look at rulers, because I guarantee you next week on Tuesday there's going to be a question with the ruler. You're going to get a ruler and you need to make sure that you measure at the 0. And this is the 0 over here. This one is the 0, not this one. Then we need to measure from the middle of that dot to the middle of the next dot, not from the end to the end. So what's going to happen is I'm going to come over here, I'm going to get my ruler, I'm going to put it at the middle of this dot, and I'm going to come over here to the middle of this dot, and when I do that, now I can see it is 2.5, 0.6, 0.7, 2.7. Now you may have got, and let's go ahead now, I got 2.7. If this was a quiz or a semester exam or a test, then I will give you credit if you got 2.6 or 2.8. Those numbers are good. I will only give 1/10 either way. That's it. So when I measure, you got to measure like I measure. So that I like this homework so that way we can explain and go over it. The next thing though, the next one says, what is the displacement? Which so happens to be the same exact number of 2.7. The next question over here says, alrighty, not a problem. Let's go ahead and let's take a glance at the distance. Now distance is both of those combined. So what I personally did was I got my ruler and I said, this is 2.7 for this distance. This distance right here, I went ahead and measured it. And when I measured it, I got 1.8. I would take 1.7. I'll give you full credit at 1.7. There you go. And then this line, I personally measured, and I got 3.7. Yeah, a 3.6, I'll give you credit. Sounds good. But again, remember, you've got to be 1/10 back either way. Here, the distance from start to B. That means when you see the word distance, you should add. When you see the word displacement, you should think straight line. So in this situation, 2.8 plus 1.8 comes out to 4.5. I'm sorry, 2.7 plus 1.8, 4.5. Double check my math, I might be wrong. Next one. Oh, sorry. Miss Munson wrote on the wrong one. But look at this though. The displacement, which is a straight line from the middle of here to the middle of here, so happens to be 1.5 also. Hey, sometimes things work out, but they don't always. So, yes, that is 4.5. Yes, that is 4.5. The distance from start to C. Now add all three numbers up. Hopefully you get something like 8.2, give or take.
Hey, Miss Munson.
We're way off?
No, I wasn't. I'm still in the 8s. I'm just, since I did those.
Crazy how if you get one wrong.
It's a domino effect. So it continues. Oh man, if you mess up on your SI units on conversion, your whole math is going to be wrong in this class. So yeah, it truly is. Displacement from start to point C.
Good thing we know we have to measure the middle to middle.
Now we know middle to middle. What'd you get here? From start to C. Hopefully you got 2.7 because that's what I got. I'm sorry. From start displacement. I'm sorry, I didn't mean to say 2.7. Oops, scoot that over. 2.3. 2.3. 2.3 from here to here. 2.3. 2.3. What would the distance of an ant be if it traveled and it crawled on this paper from the start to A, from A to B, from B to C? Wait a minute, and then back to the starting point. From C to B, B to A, and back to the starting point. What would the distance of this ant be? Well, to be honest, there's actually two answer choices. I would give you credit on 16.4 because I got 8.2 and multiplied it by 2. Or, if you argued with me and said, Miss Munson, what I did was my ant went this way, my ant went this way, and then my ant went like this and went back to start. Oh, that's perfectly good too. 10.5 works. But if you got a good argument, I'm willing to accept it. If you got a bad argument, then that's different. Next one, it says here, what would the displacement be? Mr. Smith, what's the answer? Say it again. Dang it, Mr. Smith.
0.
Whoa. Okay, let me double check. 0's right. An ant's displacement is a straight line, it says here, for the same scenario as letter G. So if my ant went and started here, and let's say that my ant went turned around and went backwards from the end to B, B to A, and A to start, then my ant would end at the starting line or starting point. Let's say that my ant started here, end, and then traveled this way. But my ant still ended where it originally started at. The correct displacement would be 0. 0 is correct. And then it says here, draw a line on this diagram that would represent a negative displacement. This one is a good example. Or how about this to the left? Because in our notes, we talked about moving down or to the left is a negative displacement. Alrighty, I'm going to skip down to question number 3. There's 2 answer choices that you can give. You can say at rest, or you can say 0 meters per second. Either one is a good answer choice for number 3. I'll put the answers for 1 or 2 on D2L. Next one, number 4. A turtle is swimming. A turtle is swimming in a straight line towards the shore. The distance that the turtle swam was 7 meters. After 5 seconds, T, it reaches the shore. What is the average speed? Speed is D over T, or 7 divided by 5. You get up with an answer of 1.4 meters per second. Remember, we like decimals in physics, not fractions, okay? We like decimals, not fractions. Let's keep going. I like number 5 because I want to show you something here to get us ready for the next unit, which is unit 2. Number 5. Number 5, though, there's a problem. Here's one of those examples in number 5 that if you messed up on one thing, then you're going to get the whole answer wrong. Take a look. Joey drives his Ski-Doo 700 meters north. Now, we are about to get to the point where we need to start doing some drawings. So let's practice. 700 meters north. Okay, there's my drawing. He stops for lunch, and then he drives 5 kilometers. It says east. He goes north, then he goes east. Let's see. There's a problem. What's the problem? No, it's 7 or 5. 7 and 5. Say it again. That's somebody y'all need to cheat off of.
I don't cheat, Miss Munson.
Oh, okay. Even better. I mean, you do good on your own. So. Did y'all hear her? Let me tell you what Miss Shelby said. Miss Shelby said, huh? Who did what? Oh, I don't know. I don't know what it. Like I said, right. Remember, I don't know. But Shelby said that this one is 700 meters, and she said this number is 5 kilometers. If you don't catch that, then when you do the math, you're going to be wrong. So does that make sense? So here's what she did. Tell us, you need to convert either meters to kilometers or kilometers to meters. What do you want me to do? Alrighty, kilometers to meters. King Henry drinks utterly delicious chocolate milk. Kilometers to meters. 5 kilometers equals blank meters. 1, 2, 3. 1, 2, 3. So that becomes 5,000 meters. So now this number right here is 5,000 meters. Now, what is the distance? Remember, distance is to add them together. So a lot of us, you did your homework, but you were wrong on this question. Your answer should be 5,700 meters is the total distance. I want to pause for a moment. I like this question because what would the displacement be? That they didn't ask me that, Miss Munson. I know, but on Unit 2, that's what they're going to ask you. Isn't displacement a straight line from the end to the beginning? Oh, how do you solve for displacement? Because that's what we're going to use that equation next unit. Pythagorean theorem. A squared plus b squared equals c squared. So that's easy. So that is going to be part of next unit. We'll make right triangles when we're finding our vectors. Let's turn the page. I know I messed up too. Here's my question. It was cut off, so I have to put it back. I know. I didn't realize it until class started, last class period. Question number 1. An object is going 50 meters per second, okay? Then starts to go 10 meters per second. Find the change in velocity. If you're going to find the change in anything, what is the math equation? What math function on the calculator? What button am I going to push? Subtract. But wait a minute. To find the difference or change, you have to do it as final first. That means 10 take away 50 equals, if you didn't give me a negative 40, the negative, then you were wrong, meters per second. Negative 40 is the correct answer. Next one, an object's traveling 4 meters per second. After 16 seconds, t, it now, VF, VI, is traveling 12 meters per second. Find the acceleration. Our notes say that acceleration equals final velocity minus initial velocity over t. So this situation would be 12. Take away 4 over 16 seconds equals, go ahead and do the math. 12 take away 4 comes out to 8 divided by 16. 8 divided by 16, which comes out to 0.5 meters per second square, is the correct units with it. Alrighty, number 16. An object moves 16 meters in 6 seconds. Find the velocity. Velocity is d over t, or 16 divided by 6. We need to go ahead and give our answer of, some of you wrote 2.6 with the line. That's perfectly good. Or you wrote 2.7 meters per second. Both of those work. The next one, number 4. I like number 4 because on number 4, it tells me here that my object's acceleration is 3. It took 10 seconds to travel, and it started with the initial velocity of 4. After it was going, what is the final velocity? It's like algebra. A equals VF minus VI over T. Fill in your variables. 3 equals VF, which is my unknown variable. Take away 4 over 10. Algebraically, you would multiply by 10, cancel, multiply by 10. 30 equals VF, take away 4. Add 4, cancel, add 4. VF equals 34 meters per second. How about that? Please take the time to go back and fix your answers if you got it wrong, because I try to do all my steps, and I will post the answers on D2L. Cancel that one. Next one. Alrighty, here we go. Looking at this one, Robert, question, what type of graph is that? DT or VT? DT, I agree. DT is correct. So that means that DTs could have curves, and don't forget, a straight horizontal line at any location means at rest. So in this situation, Abby, what's on the x-axis?
Wait, what?
What's on the x-axis?
Time.
Time. Abby, what's on the y-axis?
Position.
Correct. How far, Brian, does this object travel from A to B? Here's A, here's B. How far did it travel during this line from here to here? Let's see. 6 meters is correct. The difference right here is 6 meters. All right, Ryan, during this A to B position change, how much time does it take? 2 seconds. Now, if I put this information together on a DT graph, DT graphs tells me the speed of an object, D over T, or 6 divided by 2, which tells me that it took 3 meters per second for this object to move. Some of us got this one, but I don't expect you to get this one correct. Some of us got it wrong. What quantity is it telling me? If it's telling me the speed, the quantity is a scalar quantity. That's what they're asking you in physics, scalar quantity. We call this quantity a scalar quantity. But if it was a VT graph, that would be a vector quantity. Alrighty, I'm going to go ahead and move this out of the way. Other than